All right, this is again chapter 1.1, problem. Sorry, 1.2, problem 3. It says to graph the following and their parent functions. Okay. So here's one thing that I'm going to start talking about a little bit. We're going to start talking about the idea of inside and outside. And we're going to talk about the idea of inside is x values and backwards. Outside is y values and normal. Okay, and here's what I mean by inside and outside. Okay, I literally mean inside or outside the parentheses or the absolute value bars. Okay, this one doesn't really have an inside because there's no parentheses, there's no absolute value bars, so everything on this one is outside, so it affects the y values and the y values only. Okay. However, down here you've got these absolute value bars on problem number 2. Therefore, everything inside the value bars affects the x values and does the exact opposite of what it says. If it says subtract, you add. If it says add, you subtract. If it says multiply, you divide. If it says divide, you multiply. It is the exact opposite, and you do it to the x's. All right. Everything outside, that would be outside those absolute value bars. So like there's something multiplying up here, or there's adding out back. Those are to the y values, and they do everything to the y, and it's all normal. It says add, you add. It says multiply, you multiply. All right. Don't worry about asking why. I kind of understand why. I know the reason, but I don't fully get it. But it's one of those, just accept it and move forward. Okay? If it's inside, it's x and backwards. Inside is x and backwards. Outside is y and normal. So inside x backwards, outside y normal. Inside x backwards, outside y normal. You kind of need to drill that in your head a little bit. We're going to be using that all year long, and it's going to creep up a lot. Okay, so inside x backwards, outside y normal. Inside x backwards, outside y normal. So here we go. This one, graph the following and their parent functions. So letter A. All right. This one, it's got no squared, it's got no absolute value bars, anything along those lines. So this is actually linear. Okay, so let's kind of graph a linear real quick. So I've got y equals x, or f of x equals x is the way they've been writing it. And let's pick some points. I'm going to tell you to pick 5 points. So let's pick, since we got a 10 by 10 graph, let's spread it out a little bit. Let's do -4, -2, 0, 2, and 4. How about that? And for a linear function, well, you keep -4, -2. This is your parent function. They do not change. All right. So let's go graph that real quick. So we've got the point -4, -4, -2, -2, 0, 0, 2, 2, 4, 4. And if you can't graph it this quickly, that's fine. Pause the video and graph it. And honestly, because I don't have a straight edge, I'm going to continue these dots all the way down, so that I have something to aim for. Let me get a graph that looks like this. Again, I want you to use a straight edge. I cannot in these videos, or else I would. All right. So, remember, inside x is backwards, outside y is normal. So we're going to create our new graph. Inside x is backwards, outside y is normal. Inside x is backwards, outside y is normal. So these are all outside. For linears, everything is outside. Okay? So they all affect the y values. So follow your order of operations. We are going to multiply them by -2, because that's what's happening to x. The -2 is multiplying x. And then we're going to add 3. So here we go. Nothing is inside, so we're not going to change our x's at all. -4, -2, 0, 4. But your y's, we will multiply them by -2 and add 3. So, negative 4 times negative 2 is positive 8. Plus 3 is 11. Okay? Negative 2 times negative 2 is positive 4. Plus 3 is 7. All right? 0. 0 times negative 2, well, it's still 0. But plus 3 is 3. Oh, I skipped one. Oops. That is a positive 2 and a positive 4. 2 times negative 2 is negative 4. Plus 3 is negative 1. All right. And then last but not least, 4. 4 times negative 2 is negative 8. Plus 3 is negative 5. So now I have a list of points to graph. All right. If we're going to graph, we need a list of points. So there's your list of points. So negative 4, 11. Negative 4, 11 is technically off the graph, but 1, 2, 3, 4, we'll put it right there. Okay. Negative 2, 7. So negative 2, 1, 2, 3, 4, 5, 6, 7 is right there. All right. 0, 3, 0, 1, 2, 3. 2, negative 1 is right there. And 4, negative 5. 1, 2, 3, 4, 5. And then, again, I want you to use a straight edge. Always use a straight edge. Again, I can't because of the nature of this program. And there is your function f of x equals negative 2x plus 3. Cool? There you are. All right, let's do letter B. Let me pause real quick. All right, so for this graph, we have y equals the absolute value of x minus 3 plus 5. All right, the key terms being absolute value. You've got those absolute value bars right there. So this is an, you guessed it, absolute value function. All right, and they want us to graph both this equation as well as the parent function. So let's start with the parent function. Parent function is f of x equals the absolute value of x. Okay, and for this one, again, we have a 10 by 10 graph, so I'll spread the points out a little bit. We're going to use the points negative 4, negative 2, 0, 2, and 4. Now, when graphing an absolute value, we want 5 points, okay? I want the 0, 0, okay? Because that's where your vertex is, that's that crux where it turns. And then give me 2 on either side, okay? All right, give me that 0, 0, and then 2 on either side, so we have to have that. All right, and so the absolute value of negative 4 is positive 4, negative 2 is positive 2, 0, 2, and 4. So that's the parent function. Let's go ahead and graph it. So negative 4, 1, 2, 3, 4, 1, 2, 3, 4. Negative 2, 2, 1, 2, 1, 2. 0, 0. Hopefully you can do that really quick. 2, 2, 1, 2, 1, 2. 1, 2, 3, 4, 1, 2, 3, 4. And if you notice, this kind of gives you a nice straight line, so I'm just going to continue those dots out to the edge. We know that an absolute value is a straight line, so that way it'll help keep me on track. I won't wobble and waver. Wow, that was bad. I'm going to try that again. Better. And again, the reason I want to use a straight edge is, you believe it or not, I will get people that kind of graph like that, or there'll be no points at all. They'll kind of go like that. You laugh. I'm dead serious on that point. All right. But anyways, that's the parent function. The absolute value. All right. So let's graph the new one. X, Y. Again, we need a table of points. And remember, inside is X and backwards. Outside is Y and normal. Inside X backwards, outside Y and normal. Inside X backwards and outside Y and normal. Don't know why I'm singing, I just am. So inside, that would be inside these bars. So this negative 3, this minus 3 affects the X values. And we do it backwards. So instead of subtracting 3, we are going to add 3. Okay? So, start with all your x's and do it to all your x's. Negative 4 plus 3 is negative 1. Negative 2 plus 3 is positive 1. 0 plus 3 is 3. 2 plus 3 is 5. 4 plus 3 is, what am I doing? 7. Yeah, 4, 5, 6, 7. I can't count. I start singing, I forgot what I was doing. Alright. Outside. Outside is y, and normal. This positive 5 out here is outside the bars. So we are going to add 5 to all the y values. So 4 plus 5 is 9. 2 plus 5 is 7. 0 plus 5, well, that's 5. 2 plus 5 is 7. And 4 plus 5 is 9. So these right here, you don't have to circle the whole thing, but those are your points for this function. Okay? So here we go. Negative 1, 9. Negative 1, positive 9. That's way up here. We got 1, 7. 1, 2, 3, 4, 5, 6, 7. We got 3, 5. 1, 2, 3, 1, 2, 3, 4, 5. Stop it. We got 5, 7, 3, 4, 5, 1, 2, 3, 4, 5, 6, 7 right there. And then we got 7, 9, 5, 6, 1, 2, 3, 4, 5, 6, 7, 1, 2, 3, 4, 5, 6, 7, 8, 9. Alright. And this, and again, if you notice, you can continue it out like that. There's a point right there. That would be a point right there. Okay. And that is your new graph. Ta-da!